My name is Tommy Dickey. This lecture by Heather Junquiera and myself is based on our recently published peer-reviewed medical journal paper, which focuses on medical scent dog screening for COVID. We will describe emerging medical technologies that can utilize scent dogs as well. Heather, please explain how you got involved in scent dog research.
I started working in scent dog research a little over 10 years ago. My father was diagnosed with cancer, and it was a late diagnosis, and that really prompted me to see if there were better ways to try to detect cancer. I came across some research that was done by the Pine Street Institute, where they were using dogs trying to find biomarkers for cancer. So from then, I started working on training dogs to detect lung cancer off of blood serum to see if they could differentiate between the cancer patients and the controls. So that study was very successful, and we continued to move forward looking to figure out what the dogs were smelling in the cancer. In the meantime, COVID came around. I got a phone call from a doctor that I was friends with, and he said, "Is there any way you could train dogs to detect a virus?" And I thought about it for a while, and I knew that I had sold some dogs to the Department of Agriculture that were trained on swine flu. So that kind of launched the whole thing into looking for what type of samples we could safely use to train the dogs on to see if they could identify, COVID patients amongst controls.
Well, my entry into the scent dog world is quite different from Heather's. My research has been primarily in geophysical fluid dynamics and interdisciplinary oceanography, with an emphasis on several new emerging technologies which actually relate to the work that we're doing. However, I've also done 3,000 visits with my Great Pyrenees therapy dogs and have written 4 related children's books. During my last decade or so of teaching at UC Santa Barbara, I brought my Great Pyrenees dogs to class with me, and they became very important elements of the health program that was going on at UCSB. The dogs became campus celebrities, and this illustration here shows you one of my dogs on a dog therapy day on campus. But one of the more interesting things that we did during our many years there was that we participated in a drive to vaccinate UCSB students for a very rare form of meningitis that had just been approved for use at Harvard. So my dogs came to campus and became even more celebrity-like at that point. We've also done therapy dog demonstrations at the Los Angeles, California Science Center, where I became fascinated with the science of dogs' sense of smell. So I put together a program for Los Angeles Public Library children about dogs' sense of smell. And on top of that, I decided I was really going to get into deep research about the potential use of scent dog detection of COVID. During this really deep literature search, I came across Heather, and she was one of the people who responded to a survey I had put out about what was going on with the COVID detection research. And at that point, I asked Heather if she would kindly join me in writing a peer-reviewed article on the COVID scent dog research, which was ongoing, as well as her own work. Okay, our lecture has 6 parts. The first 2 parts will be given by Heather. They're on dogs' amazing sense of smell and medical scent dogs. In part 3, I will focus on the temporal evolution of the COVID infections and describes the performance of this currently commonly used testing methods. In part 4, Heather will review the recent COVID scent dog research. In part 5, I'll introduce some emerging technologies that can benefit from mimicking scent dogs. And finally, I'll provide some conclusions of our research. Heather?
Dogs have an amazing sense of smell. I think that a lot of times people don't realize just how intricate the dog's noses are and why they work the way they do. One way that I like to explain to people is kind of comparing the difference between our noses and their noses. A lot of times people will notice that we will go nose blind to an odor, and that's because we breathe in and out the same passages in our nose. So eventually we quit smelling that odor. But dogs have passages they breathe in, and then they expel the odor that they don't want. So they can actually accumulate odor in their nasal passages to help them identify the world around them. And that's really one of the key factors that makes them such amazing workers in the scent detection world. They have an actual part of their nose called the vomeronasal organ, and that is completely dedicated to scent, as well as a part of their brain that is solely dedicated to scent. So they are really made and driven by scent. That's what we try to tap into, is how to understand how they're smelling and how to get them to understand the alerts that we want off of specific odors. Dogs have hundreds of millions of olfactory receptors. One way I kind of like to explain this to people, because a lot of times people, the words itself, it sounds impressive, but they don't really fully understand what those do. So one little example that I like is if you were to walk into your house and someone was cooking spaghetti, you would come in and be like, oh, someone's making spaghetti sauce. When a dog will walk into the same room, they could identify every single ingredient in that. They would say, oh, I smell garlic, I smell tomatoes, I smell salt, I smell pepper. So for them, everything is separated and very individual and specific. That's one of the reasons that dogs are able to find substances. Like, for example, a dog that is trained to pick out drugs can find drugs when people try to encase them in peanut butter or in coffee and all these distracting odors. You cannot fool them. They still know that it's there and they can still find it because they smell each individual odor as opposed to a combination of odors. Okay, Tommy, would you like to explain about your cup experiment that you did?
Sure. Okay, so in the process of teaching children about how dogs smell, I decided I'd use my own dog. So in this particular illustration, you see my two Great Pyrenees being trained to basically find a treat underneath 3 cups. This is called the 3-cup experiment. And the object of the exercise for this is to illustrate that dogs are able to find something, whereas an individual would walk up and you would ask them, where's the treat of the 3? So it's like the old shell game, basically. And so, of course, the dog always wins because it can smell the treat, which is underneath one of the 3 cups. So you can move around, do whatever you want, do the shell game. The dog always wins. It's kind of a cute little way of showing this. And basically, the COVID dogs are trained in a very similar way, with rewards of treats or play, sometimes using clickers for some researchers.
Yeah, Tommy's very correct in that with our training methods for the type of scent detection work that we do. Most of the dogs we're working with are food reward. Some scent dogs are trained with play reward. Ours are trained with food rewards. So it makes it quite easy because we simply start this exact way with training the very young dogs to find a treat.
Go find it.
So they learn the word find it. We hide treats in various different things. We hide under cups, we hide in the grass. They learn the word find it and to find a treat. Then we're able to take the target odor we want them to learn and pair it with the treat. So once we pair that odor, we gradually start taking the treat away. The treat becomes smaller and smaller and smaller until there's no longer a treat, and the dog is just picking out the target odor that we're wanting them to indicate on. These are just some examples of some of the research that is going on using scent detection. The dogs are being trained on malaria, cancer, diabetes, Parkinson's, and this is really just the tip of the iceberg in how people are really starting to try to use the dogs to see how they can help people in society. Some different areas have different focuses. The main focus, I believe, with cancer detection is to figure out what the dogs are smelling to create a better diagnostic tool. Whereas with diabetes, the dogs are actually used to indicate on the person to let them know if their blood sugars are dropping too low. Sometimes people wear the GCM monitors, they malfunction. So the dog is a great extra line of defense that can potentially save that person's life. So there are multiple different ways that the dogs can be used. They can be used in the research setting, looking for biomarkers, helping to develop new and exciting tests for diseases. And they can also be used to actually indicate on people, which is where the COVID detection seems to be moving very rapidly into that direction to screen large groups of people quickly.
Okay, now we'll move into a little background on the specific application for these medical scent dogs, that being the COVID-19 infection. This particular time series is very important with respect to the sampling for COVID. So on the left vertical axis, we have the viral load, or if you like, the concentration of the virus. The three phases of the virus's evolution are incubation, shown there at the top on the left, infectiousness, where you also have symptoms, and then clear on the right on the top is the post-infectious period. All three very important periods. The curve is extremely important in showing the very fast transition to the infectious phase. So where the rise is occurring, it happens within a day or 2 days at most, typically. So it happens fast. That curve rises fast, which is very, very important in terms of sampling, so that one needs to be sampling very early on for any indications of the virus. And latent periods for getting analysis and results back becomes problematic. So this curve shows that extremely well. So we see the rapid advance, but the duration of the infectiousness is still rather uncertain. You see the curve kind of slopes off, not as rapidly, and in fact is rather uncertain. So this is a conceptual diagram, but this shows the general nature of the evolution of the infection, so that it's important to know what the sensitivity of the test may be that you're going to be looking at the COVID virus with. So the low sensitivity rapid antigen test is shown in the dotted line across the top, and the high sensitivity RT-PCR test is shown in the lower line. These series of slides show you and certainly indicate that timely testing is vital for limiting the spread of COVID, which is still a very major concern. In fact, many people are now asking, do we really need to have these tests or not, since we are moving into a phase where, at least in the United States, a very high percentage of individuals are being vaccinated or will be vaccinated in the future. So again, is testing really important at this point? And we would argue that yes, indeed, it's still very, very important for a series of reasons. First of all, there are new mutations and variants, such as the B117, which need identification. And there are 3 or 4 more variants which are starting to take hold, not only in the United States, but around the world. So we need to identify those. They're not going to be identified unless we have sufficient testing. In the United States, there are new restrictions are being lifted, and schools are starting to be opened again. So that means a very large population of individuals are going to be exposed again. We need to know, for example, if our children going to school or college students are still testing positive for any form of these COVID variants or mutations. Vaccines and tests are not 100% effective. So people can still be contagious even though they have been vaccinated with one of the major vaccinations which are out there. So there are some people, some low percentage, but some percentage of people are still actively contagious. Of course, many people in the United States and around the world will not want to be vaccinated or even tested. So that's another reason that we do need to continue to focus on testing and encourage people to have these tests done. Importantly, there are many nations that still lack both the testing and the vaccinations. As of the recording of this lecture, India is facing major problems, and is over 3 million people around the world have already passed away of this virus. So it's a worldwide phenomenon, it's a pandemic. And so testing remains to be very important. And that's one of the reasons that Heather and I are focusing on this particular aspect. The 2 major tests that are being done commonly are the RT-PCR test. This is the most reliable of the tests which are out there right now to the general public. These have very good sensitivity and selectivity, meaning that the first part of the curve there on the left, you'll see that this particular test will pick up the COVID better than the antigen test. And it's very selective as well. It works quite well. So it's a good test. It's considered the gold standard of the COVID tests. This test requires nasal or throat swabs, and it takes a relatively long time to get the results back. And in fact, it's quite expensive as well. One of the downfalls of this particular test, if you like, is that it may give false positives later in the evolution when a person may be post-infectious. So if you look on the right of the curve there, you'll see a red dot going along with the high sensitivity PCR test and a green dot for the antigen. So in this case, one would argue that perhaps this false positive could be a problem as well. The antigen test has much lower sensitivity, as shown by the dashed line at the top there. And so it doesn't pick up the COVID as quickly as I indicated before. You get a green light that you're safe, whereas you actually do have the COVID. So that can be problematic for its lack of sensitivity. Nasal and throat swabs are also used for this test. The results come back fairly quickly, within 30 minutes or so at this point, and it's relatively cheap compared to the RT-PCR. However, the major constraint upon this particular method is that it gives false negatives far more regularly than the RT-PCR, or as Heather will talk about later with the dogs. False negatives are extremely important because that means that somebody thinks that they're not carriers of the virus when in fact they are, and this can lead to the spread of the COVID virus. There's been a very large amount of controversy associated with this particular aspect and with the antigen test to the point where it's been stopped in its usage in some countries because they're afraid that rather than being a help for the problem, it's actually a problem itself in spreading the virus. Okay, Heather's going to tell us now a bit about the COVID scent dog detection work.
One thing I'd like to touch upon is research that it's really exciting research that we are just now getting into with the scent detection dogs, and it relates to the PCR testing and the antigen testing. So one of the biggest questions with the dogs is how quickly and how early can they detect an active COVID virus in a person. So we are working right now screening live individuals at different events and collecting data from those events. And the preliminary research on it is really quite exciting. We've had cases of people. We had one particular case of a young man who was fully vaccinated and the dogs indicated on him, and his antigen test was negative, and 3 days later his PCR was positive. So that's, for us in the scent detection world of the dogs, it's very exciting to start collecting that type of data to see where on that scale the dogs are going to fall. I think the dogs present a possibility of being an amazing screening tool in conjunction with the other tests. So as the data comes in, we move forward doing more events where we're screening more live people along with organizations who are also doing the antigen test and the PCR. We'll really be able to get an accurate gauge on how well the dogs are doing. So the dogs all start out on canisters looking for a treat. As they get older and our older dogs we're working with, we start to add the COVID odor. And what the dogs are being trained on, they're being trained on breath condensate and sweat samples from people who are positive for COVID. We try to get a large number of samples to train the dogs on, because say you only use 5 samples to train the dogs on. In fact, you wouldn't really be training them on COVID. You would just be training them to identify 5 people's breath condensate. So you have to use a very, very large sample number to help the dogs to learn to discriminate what's the common denominator between all of these samples. So for this end of the research, that is our biggest challenge, is getting enough samples to train the dogs properly on, and also getting samples from people who are not showing symptoms, because we really need to make sure that the dogs are picking up someone that's asymptomatic, because that's the person that could potentially be in the crowd or going into the school who could infect other people unknowingly. So that's really where we're working hard to develop better ways of being able to train the dogs on the virus. Their accuracy rate has been well above 95% in almost every single study that we have reviewed. It's consistent across the board around the world, from studies done here in the US to studies done in France, studies done in Dubai. All of the researchers involved, we're all getting the same results, which is very exciting and very encouraging. This is how we start them out. So the puppies are actually looking for a treat on their very first training sessions. Within a week, we're already putting a COVID sample into those canisters. And we let multiple puppies in at the same time because it's the challenge to find the food first. So that really motivates them. And as you see, when they come in the room, their little noses immediately start going and track to the source of the odor, which in that case, they're looking for the food because that is their reward. As they grow up over time, they will realize that they get that same treat for finding the target odor as well. The older dogs, once they start to progress, we will start to simply put samples in the canisters. Sometimes we put canisters on the ground, sometimes we put canisters on the wall. And then eventually we transition to individuals like volunteers holding the canisters and hiding them in a group of people, so we can teach the dogs to track through a group of people to the source of the odor. A participant in one of our studies called me up and said he had tested positive. I was quite excited to have the opportunity to take a dog to screen on him. The dog in the video, it was the first time screening on a live individual with COVID. And you can see as the dog passes by, it catches the scent in the air and then stops. And for the dog, I have a feeling the odor is much, much stronger coming from the individual than coming from our samples. So the dog was quite excited to find that target odor that he was looking for and to get his treat. So this slide talks about the French study. In this study, they trained Belgian Malinois, and these dogs were trained very, very rapidly. The reason they were able to train them so rapidly is because they had previously been trained on other odors. So they knew that they were going to be looking for an odor. They just had to be taught what type of odor they were going to be looking for. They had an incredibly high success rate. It was a great study to show that, yes, dogs, can be used to identify samples that are positive for COVID. In practicality, you could not use these dogs to screen people for COVID because they could possibly be picking up the previous odors they had been trained on. So COVID detection dogs really need to be single purpose, because if they've been trained on explosives or on drugs or on cancer, they could be indicating on that in someone in a crowd as opposed to just indicating on COVID. But I have a feeling with this study, they were purely just wanting to see if the dogs could do it. And then I'm sure they'll move forward with single purpose dogs. And this is a slide about the German study. This was nice because they used a variety of different breeds of dogs in their study. Again, they had an incredibly high success rate. They ran multiple trials with these dogs. And what makes this one a little bit different is they used saliva in their training. I think what this is telling us is the odor that the dogs are picking up, it's coming from the volatile organic compounds, which come out in our sweat, in saliva, in tears, and in urine. And I believe that Penn Vet is just releasing a study where they use urine to train a group of dogs with great success as well. This is from the Colombian study. I think one of my favorite parts about this study is the inexperienced pit bull that they used in it. Again, nice to see the variation in using different dogs in the study and their accuracy rates that they have. one of the big questions that comes up with these different studies is what breed and why. And I see a lot of studies that have been done, especially overseas, have used German Shepherds and Malinois. I don't believe that's because they have better scent capabilities. It's the availability of the dogs. These are the type of dogs that are used by the military, by the police, and they're generally, dual purpose dogs for them. I am partial to the hound group because of their number of olfactory nerves. So we, with our research, we predominantly use beagles because they're very, very, very scent driven. But there are multiple breeds that have the same, capabilities to do the work. This is talking about where dogs are currently being used. So the Helsinki airport has a pilot study going on, and the medical scent detection dogs in England met with the Ministry of Health there, and they are talking about using the dogs in the airport. So that's really, really exciting. I can't wait to see how they're going to move that forward, if it's going to be in a study fashion or if they're simply going to start using them to screen. There's one study in the United Arab Emirates. They are using dogs in the airports, and the way they're using them, it's a little bit different. The dogs are not screening the people directly. They are taking a small tube that collects odor, and they place that tube under their arm. And then that goes back to a laboratory setting where the dog sniffs the canisters and chooses if one of them has COVID or not. That process, it takes a little longer, but I believe that it eliminates a lot of distracting factors for the dog. So they're able to really just focus on the scent. The only disadvantage to that is it takes a lot of time. If you are trying to screen thousands of people in a day, that could become very cumbersome. So this kind of goes back to what I got excited about and had to kind of jump in on right at the beginning of talking, is where we're trying to figure out where the dogs are going to fit on this scale. So that's the biggest question we have. When I take dogs out to, events to screen, everybody's like, okay, where, how soon can they pick up before it? Can they pick up after? And so far, the preliminary research is showing that they're definitely picking up well before the antigen test and a few days before PCR. So as we get more data in, it will be really excited to share to see where we think the dogs fall on this scale. And if they fall where we think they're going to fall, they're going to be a great tool to use moving forward in society to help make events safe and get things back up and active where people can have conferences, they can go to concerts in a safe and responsible way. The other thing about the dogs is they're non-invasive. A lot of times people don't want to submit to a test because it's uncomfortable. But what I've seen with my experience, once the dog hits on them, they're more than happy to go get the test because they know they need to know if they are positive for COVID or not. One thing that I didn't anticipate with taking dogs into large areas for screening was the psychological effect that the dogs would have on the crowd. We took our beagles to a filming set, and the stress level of everyone seemed to really drop. And I was really quite overwhelmed with people thanking us for bringing the dogs there, for keeping them safe, that they didn't feel anxious.
In this final section, we'll describe how scent dogs may be used for developing new disease detecting technologies. Biomimicry is defined as an imitation of animal functions for innovative kinds of research and designs. Good examples are the hummingbird, which has been used for the design of helicopters. Ship drag has been reduced because of studies based upon shark skin. So basically mimicking shark skin, and even Olympic swimsuit design has benefited from the studies of shark skin. The last example is with the camel. Camel's breathing has been researched to improve desalination plants. There are numerous other examples where basically it's like reverse engineering, that we look at an animal and figure out how they're doing it. And through their evolutionary process, they're basically able to do things that takes a lot of energy and time and money to develop in a traditional way. This illustration shows you the dog's nose plus the dog's brain, and we just heard what all of the amazing things they can do with all their sensory receptors, and their processing with the brain is just totally phenomenal. What they can do, most of their brain is associated with smell, opposed to humans. So that's one of the really important things from all of this. And one thing that's kind of interesting, if you take a look at it, is a room full of scientific instrumentation, such as gas chromatographs and mass spectrometers, would be required to approach the odor detection capability of a dog. So you've got a dog and you've got a room full of instrumentation. And basically, the reverse engineering is what people are trying to work on with the development of these new devices called e-noses, which I became interested in doing my ocean research and trying to find new sensors that could chemically measure different kinds of very, very small concentrations of things, but with very, very limited size, basically a miniaturization process, if you like. So e-noses are being designed to mimic dog smelling sense and could potentially be used to identify disease signatures. This flow chart illustrates how e-noses may be able to mimic dogs' noses with sensor arrays, shown in the bottom left there. Also, artificial intelligence-based data analysis may be used to simulate the processing power of a dog's brain. And so the dog can do it. They just do it naturally, but we have to basically figure out how to do this in terms of both the sensor part, and then fortunately we do have artificial intelligence, neural networks, et cetera, which people are working on, which give us at least a fighting chance to try to match what the dog is doing. And finally, wearable medical sensors like the ones shown in these photos are beginning to be used for fundamental physiological data as listed here. So commonly, people are now using the device in the upper left corner to measure their glucose. So you have a time series of glucose that you can look at for people who are type 2 diabetics. The device down below that is from UCSD, and it's really quite interesting in that it's very non-intrusive. Basically, it's like a gauze that will fit on your skin and basically serve to give out data types such as heart rate, blood pressure, oxygen, skin temperature, and glucose in the future. So it's in the wave of future and something being done in the UC San Diego research community. Of course, in the future, we expect that e-noses will be able to detect a variety of diseases. So even when COVID is over, if it is over anytime soon, hopefully this is cutting edge research utilizing dogs that can improve the whole diagnostic schemes for medical problems that Heather talked about earlier on. There's been a lot of information that has come out about what dogs can potentially do, but as yet, they're not really used in a routine sense for community-wide sensing of diseases. But it certainly looks like it's something that we should be taking advantage of. Few conclusions: the dogs can provide quicker, non-intrusive, and highly accurate screening for COVID. Again, matching the RT-PCR, yet not having the problem of being intrusive. No samples are necessarily taken. And of course, they're quicker. They can do their job within seconds, whereas it takes quite a long time to process the data. Where can the dogs be used? Lots of places: hospitals, senior centers, schools, colleges, airports, train stations, ports, sporting events, and entertainment venues. And already, as Heather indicated before, they are starting to be used at airports and sporting and entertainment venues. And there have been a few other examples where they've been used in colleges, and a couple of cases actually in senior centers. So there are a lot of places these dogs can be used for direct diagnostics. Scent dogs can be used for future pandemics and detection of other diseases. Even when this pandemic is over, hopefully it will be over soon. But at the end of the day, there will probably be other pandemics as well. And hopefully we're setting the stage and helping encourage development of new sensors, et cetera, that can get very quick and accurate measurements that relate to diagnostics of all different kinds of diseases And these can be done in even a wearable biosensor kind of a context, or they could even be used with smartphones at some time in the future. And thank you for listening to this lecture from Heather and me.